Welcome to my presentation. In this presentation, we shall see an example related to limits. We want to find, let me take an example here. We want to find the limit of this function, limit of x squared minus 1 divided by x minus 1 as the limit x approaches 1. Okay. Now, to do that, I'm going to solve this problem. I'm going to break it down into these different steps. Step number 1. Let us graph this function. Let us graph this function f of x. If f of x is equal to x to the power of 2 minus 1 divided by x minus 1, to be able to graph this function, we want to construct the table of values, and to do that, we're going to make a table for ourselves like this. We'll make a table for ourselves, and then we're going to give some values for x and then find the corresponding values of the function. When the value, we'll pick some points on the x-axis, on the negative x-axis, and some points on the positive x-axis. When the value of x equals to negative 3, the value of the function is going to be equal to negative 2. What we are doing here is we are substituting the value of x as equal to negative 3 in the given function. Negative 3 raised to the power of 2 minus 1 divided by negative 3 minus 1. When we simplify the math, that is going to be equal to negative 2. When the value of the function is negative 2, when the value of x is equal to negative 2, the value of the function is going to come out as negative 1 by substituting the value of x as equal to negative 2 in the given function. When the value of x is negative 1, the function simplifies to a value equal to 0. When the value of x equals to 0, when we substitute the value of x equals to 0 in the function, the value comes out as equal to 1. When the value of x equals to 1, we see that 1 squared minus 1 is 0. In the denominator, 1 minus 1 equals to 0. So therefore, 0 divided by 0, that is going to be undefined. We'll write that as undefined. Let's keep going some more, and I will explain what is happening here in a minute. When the value of x equals to 2, the value of the function is going to come out as equal to 3. When the value of x equals to 3, the function simplifies to a value equal to 4. So this is what is called constructing the table of values. Now that we have constructed the table of values, we're going to graph this. We're going to plot these points on a graph sheet, and to do that, we're going to draw a graph sheet for ourselves. And then if we call this as the origin, and if we pick some points on the positive x-axis, 1, 2, 3, and on the negative x-axis, negative 1, negative 2, negative 3, and then if we were to pick some points on the positive y-axis as 1, 2, 3, and 4, and on the negative y-axis as negative 1, negative 2, negative 3, like that. And now we are ready to plot these points out, and when we plot them out, it is going to look like this. Let me get this here like that. Yeah. Okay. Now, when x is equal to negative 3, the value of y is equal to negative 2. The value of the function is negative 2. So we are right there. When the value of x equals to negative 3, the value of y is negative 2. That is the first point. When the value of x equals to negative 2, the value of y is negative 1. Negative 2, negative 1. That is the point. when the value of x equals to -1, the value of y is equal to 0. So it is right on the x-axis. That is a point. When the value of x equals to 0, the value of y is 1. We got that point. That is the point. When the value of x equals to 1, the value of y is undefined. We'll come back to that point in a minute. When the value of x equals to 2, the value of y is equal to 3, right there. When the value of x equals to 3, the value of y is equal to 4. We got all the points now. We got all the points. If I were to pick another color here, and then if I were to draw a line passing through all these circles here, it is going to be a straight line. If you were to draw it to scale on a graph sheet, you will see that it is going to pass through all these points. The thing which we want to observe here is that as x is approaching 1, I'm going to put a dotted line there. The value of y is approaching 2. So I'm going to put a green circle around that, according to the table of values. As the value of x is approaching 1, the value of the function is undefined. But according to the graph here, as the value of x is approaching, let me state it this way, as the value of x is approaching 1, closer and closer to 1, the value of the function is approaching 2. The value is approaching 2. So what it is telling us is, it does not matter that f of x is undefined at x equals to 1. What matters is the limit depends only on the value of f of x very close to x equals to 1, not at x equals to 1. Therefore, what I have done here is I have a missing point. I am denoting the missing point by an open green circle. Okay. Now we can explain the same concept by explaining it with the help of limits. So in here, I'm going to, as step number two, I'm going to take this one as limit of this function x to the power of 2 minus 1 divided by x minus 1 as x approaches 1. How do we simplify this? We're going to substitute the value of x equals to 1 in here. 1 raised to the power of 2 minus 1 divided by 1 minus 1. 1 squared is 1 minus 1 divided by 1 minus 1. The numerator is 0, the denominator is 0. Therefore, these types of values, this is undefined. And this is what we have seen in the table of values above in the table. We can also explain the same concept by picking points very close to x, very close to the value 1, and then then observing that the function is going to be undefined at the point when x is equal to 1. So let me construct another table of values in here, and in this case I am going to give values to x and find the corresponding value of the function. And then in this case, in the middle of the table, I'm going to say as the value of x approaches 1, the value of the function is going to be undefined. I'm going to represent undefined as u and d for simplicity's sake. If I were to pick a point very close to 1, which is going to be equal to 0.999, very close to 1, and then if I were to plug in the values into the given function, the value of y is going to be equal to 1.999, like that, on the left hand side. If I were to pick a point very close to 1 on the right hand side of it as 1.001, very close to 1 but not equal to 1, the value of the function is going to be equal to 2.001. Again, if I pick another point on to the left of 1 as equal to 0.999, 1.990, the value of the function, f of x is going to be equal to 1.990. And on the right hand side, if I were to pick a point very close to 1 but a little greater than 1, which is going to be equal to 1.010, the value of the function is going to be 2.010. You can try this thing out. You can plug in these values into your calculator and find the corresponding value of the function. If I were to pick one more point on the x-axis, and if I were to substitute the value of x equals to 0.90, the corresponding value of the function comes out as equal to 1.90. And on the right hand side, if I were to pick a point very close to 1, which is 1.10, the value of the function is going to be equal to 2.10. So this is how this is what we are looking at. This is another way of proving that the limit as x is approaching 1, the value of the function is approaching 2. So let me state this in here as follows. As x is approaching 1 from the left, as x approaches 1 from the left side, the value of the function, the value of this function is going to approach to 2 from the left. So as the value of x approaches 1 from the left, the value of the function is going to approach the value equal to 2. Similarly, as the value of x is approaching 1 from the right, the value of the function is approaching 2. The value of the function is approaching 2 from the right. So, but at x equals to 1, the function is undefined. So if I were to come back and then state it again, it does not matter that f of x is undefined at x equals to 1. What matters is the limit depends only on the value of f of x very close to x equals to 1, not at x equals to 1. So this is how we can solve problems of this nature. In my next presentation, we shall see the definition of a limit of a function.